continue on, we're looking at the double angle, half angle, and reduction identities today. But first, did you two do the extra credit opportunity? Okay. Double angle identities for 3 of the trig functions. First, we have sine. Sine of 2 theta, 2 sine theta cosine theta. For cosine, we have actually 3. Identities. No, it's called 3 forms of the identity. The most commonly used one is cosine 2 theta is cosine squared theta minus sine squared theta. But you can also have 1 minus 2 sine squared theta, or 2 cosine squared theta minus 1. And finally, for tangent, tangent of 2 theta, 2 tangent of theta over 1 minus tangent squared of theta. Now for the reduction identities. Not to be confused with reduction formulas that we're learning in Calc 2. Again, there's a reduction identity for each of sine, cosine, and tangent. Sine squared of theta, 1 minus cosine of 2 theta all over 2. Cosine squared theta, 1 plus cosine 2 theta all over 2. And tangent squared of theta, just sine squared over cosine squared, so 1 minus cosine 2 theta over 1 plus cosine of 2 theta. And finally, we have the half angle identities. Again, 1 for each of sine, cosine, and tangent. Sine theta over 2 plus or minus the square root of 1 minus cosine theta all over 2. Cosine theta over 2 plus or minus the square root 1 plus cosine theta over 2. And finally, tangent of theta over 2. Again, there's three forms, just like there was with the cosine 2 theta. Plus or minus the square root 1 plus cosine theta over 1 minus cosine theta. Or sine theta over 1 plus cosine theta. Or 1 minus cosine theta over sine theta. The plus or minus that's in front of the square roots is determined by the quadrant that theta over 2 is located in. Now, last time we did these, right? But we used the sum and difference identities. Here we're going to use the half angle. Pi over 12, pi over 6 divided by 2, right? So pi over 12 is half of pi over 6. Pi over 12, first quadrant. Sign is positive in the first quadrant. So it's the positive square root. 1 minus cosine of pi over 6 all divided by 2. Cosine pi over 6 is root 3 over 2. Simplify your compound fraction. Square root of 4 is 2. Sine pi over 12, square root of 2 minus square root of 3, all over 2. But what did we say sine of pi over 12 was on Wednesday?
Square root of 3 plus 1 over 2 square root of 2.
What was it?
Square root of 3 plus 1 over 2 square root of 2.
Plus?
Yeah. Oh, so that's 5, 5. No, square root of 6 minus square root of 2 over 4.
Or 3 minus 1 over 2 root 2, right? They're the same thing. Sine pi of 12 can only have one value. That means they're actually the same number. Just different forms. Again, pi over 12, quadrant 1. Cosine is positive in quadrant 1, so we take the positive square root. Cosine pi over 6, still root 3 over 2. Simplify a compound fraction. Square root of 4 is 2. Square root of 2 plus root 3, all over 2. That was cosine pi over 12 from Wednesday, right? But again, cosine pi over 12 can only have one value. So same number, different forms. Fine, let's look at tangent pi over 12. We have three forms to choose from. First one, square root of 1 plus cosine, sorry, 1 minus cosine over 1 plus cosine. Pi over 12 is quadrant 1, tangents positive in quadrant 1, so we take the positive root. Or we said, it was sine of theta over 1 plus cosine of theta.
So when it's like saying cosine pi over 6, you go to the unit circle and you find pi over 6, and then the cosine value, that was going to be the top. Okay. So then on the unit circle, you go to sine, or you go to pi over 6 and then find sine.
Sine pi over 6 is 1/2. Clear up the compound fraction. 1 over 2 plus root 3. Or is that could also be 1 minus cosine all over sine. And when you clear out the compound fraction, 2 minus root 3. So all three of those are the same. And that shouldn't be difficult to see just by doing rationalization. But that was from Wednesday. Tangent of pi over 12 can only have one value. Those are all the same.
So any of those answers would be right,
Mhm.
or the one on the
It
right?
depends on how you do it.
So on Wednesday, you guys learn a different way, and then that's that. Okay.
Wednesday, we do the sum and difference identities.
Okay.
I'll come back to this one if I have time at the end. And to rewrite this as a single function,
Would that just be,
2 times sine times cosine.
would that be sine 275? Mm.
Two sine theta cosine theta is sine of 2 theta. And that's sine of 2 times 75 degrees or sine of 100 degrees. One minus 2 sine squared 37 degrees. One minus 2 sine squared of theta is cosine of 2 times theta. Twice the 37 is 74. That's cosine 74 degrees. Square root 1 minus cosine of 84 degrees over 2. Isn't that the half angle for sine? That'd be sine of 42 degrees. Because you have to make sure that that is correct. Sine of 42 degrees. 42 degrees is in the first quadrant, right? Is sine positive in the first quadrant? Yes, that's right. If it wasn't, we just have to multiply by minus 1.
So just a higher number?
If sine wasn't, yeah, if sine wasn't positive in that quadrant, you just have to multiply it. Square root 1 plus cosine of 160 degrees over 2. 160 over 2 is 80 degrees. That's quadrant 1. Is cosine positive in quadrant 1?
Yes.
That's just cosine of 80 degrees. Sine 142 over 1 plus cosine 142.
What's the tangent?
This is half angle for tangent. And there's no special considerations. The only one that's plus or minus is the one that's square root.
So it would be tangent 142 divided by 2.
It's tangent of 71 degrees. One minus cosine of 184 degrees over sine of 184. It's half angle for tangent again, no special considerations. It's not 91.
What do you mean by
Tangent of 92 degrees.
What do you mean by no special consideration?
It's not, you don't have to worry about plus or minus. Exact value, sine of 292.5 degrees. Two 92.5 would be 585 over 2. $585 degrees. What quadrant is that?
Two. Three.
Yeah, it'd be third quadrant. Sine, positive or negative in the third quadrant?
Negative.
Negative. So we need to take the negative square root. 585 is beyond 360. Find the coterminal. (585 minus 360, 225 degrees. And 225 is on the unit circle. Cosine 225 degrees, negative root 2 over 2. One, two. Negative square root 2 plus root 2 all over 2. Sine pi over 8. Pi over 8, isn't that half of pi fourths? Which is in quadrant 1. Square root of 1 minus cosine pi over 4 divided by 2. Clear out the compound fraction, simplify square root of 2 minus square root of 2 all over 2. Fix that real quick. Sine is 5/13, theta is in the second quadrant. Find sine theta over 2, cosine theta over 2, tangent of theta over 2. First thing to notice. Theta's in the second quadrant. We know it's between pi over 2 and pi. Which means theta over 2 between pi over 4 and pi over 2. Which makes cosine positive. In fact, all sine, cosine, and tangent will be positive. And theta over 2 is in the first quadrant. Or theta isn't, so I'm going to need theta prime, the reference angle for theta. You should recognize this is a 5, 12, 13 right triangle. I actually am not going to need sine of theta. You can get away with just cosine in the 3 half angles. That I want to take here. I guess it doesn't matter. Right, cosine of theta is negative cosine theta prime, because we're in the second quadrant. Negative 12/13. Sine theta over 2, 1, the square root 1 minus cosine theta all over 2.
The first one here is the negative 12 over 13.
We need to clear out compound fraction. (13 plus 12 over 26). root 25 over 26, or five over the square root of 26. Or you could rationalize that if you wanted to. Cosine theta over 2. Square root 1 plus cosine theta over 2. And everything is essentially the same except that the sign switches. One over root 26. We had a few we could choose from. Stick with that. Clear out the compound fraction. Okay, it's just square root of 25. Cosine theta is 3/7. Theta is in quadrant 4. If theta is in quadrant 4, theta is between 3 pi over 2 and 2 pi. Oops, not theta, sorry. Meaning that theta over 2 is between 3 pi over 4 and pi, which is the second quadrant. We're going to have to use theta prime. Pythagorean, that missing length is 2 root 10. And 49 minus 9, 40, square root of 40, 2 root 10. Oh, I didn't need to do that, did I? I actually did not need to do
Now,
that,
what this is 3 over 7,
because all I need is cosine.
and that's given to us.
So I'll leave that there, but I will duplicate. And in my duplication, I'll get rid of this. I just need to know what quadrant theta over 2 is in, and I just need cosine. In quadrant 2, sine is positive. Square root.
You say 1 and 4 or 2?
Theta over 2 is what we're looking at. Square root of 1 minus cosine theta over 2. Clear out compound fraction. Square root of 4 over 14. Two over the square root of 14. And again, we could rationalize that if you wanted to. In quadrant 2, cosine is negative. Negative square root of 1 plus cosine theta over 2. Negative root 10 over 14, which does simplify. Write it. Do I do a single square root, separate square roots.
Separate.
I think separate would look nicer. Negative root 5 over root 7. Finally, tangent. Quadrant 2, tangent's negative. Negative square root 1 minus cosine theta over 1 plus cosine theta.
Why are we looking at the quadrant 2? If the question says quadrant 4?
That's for theta. But we're doing just theta over 2. Four there. 3. Negative square root of 4/10. Negative 2 over root 10 is tangent. Start with the right hand side. Cosine to the 4th x minus sine to the 4th.
You can simplify it by taking the square or taking it out.
That's a difference of squares. Cosine squared plus sine squared. And then cosine squared of x minus sine squared of x. Isn't that the double angle identity on cosine?
Mm-hmm.
So we get cosine of 2x, which is what we wanted.
Or I put an X in the box.
Easier than filling it in. Again, let's start with the right-hand side here. Not difference, sorry. Sum of cubes. Now look, sine plus cosine over sine plus cosine is 1. Addition is commutative and associative. So how we order and how we group doesn't matter. Sine squared plus cosine squared is 1. Sine x times cosine of x. If you look at the double angle identity on sine, sine 2x is a half sine x cosine x, right? Solve for sine x cosine x. Sine x cosine x would have to be a half sine 2x. Which is what we wanted. Okay, this one's kind of a. Let's start. Start with the right-hand side. One minus tangent squared x over 2 divided by 1 plus tangent squared x over 2. I'm going to do this though. I'm going to rewrite for now. Do a change of variable for right now, just to make it look nicer. So say theta is x over 2. We'll have 1 minus sine squared over cosine squared divided by 1 plus sine squared over cosine squared. Clear out the compound fraction. I'll actually show because this is approved. We'll multiply by cosine squared over cosine squared. Cosine squared plus sine squared is 1, right? So that's nice. Cosine squared minus sine squared. Is that cosine of 2 theta? But we said theta is x over 2. And so just replace theta with x over 2. You're going to get cosine of 2 times x over 2, which is just cosine of x as desired. Two tangent of 2x equals this. This is what we want to prove. Again, probably easier to start with the right-hand side. Multiplying the first fraction by a cosine x plus sine x over cosine x plus sine x. Multiplying the second by cosine x minus sine x over cosine x minus sine x. If you expand out the first numerator, that's what you'll get, right? Cosine squared plus twice cosine sine plus sine squared. Expand out the second. Cosine squared minus twice cosine sine plus sine squared. And then in the denominator, that is a difference of squares. That gives you cosine squared minus sine squared. But look, let's use red. You have cosine squared minus cosine squared. You have sine squared minus sine squared. Notice then what we're left with in the numerator. 4 cosine times sine, right? Over cosine squared minus sine squared. However, multiplication of real numbers is commutative. We can write cosine times sine as sine times cosine. Can write 4 as 2 times 2, so we can write 4 sine x cosine x as twice of 2 sine x cosine x. But 2 sine x cosine x is not just sine of 2x. And cosine squared of x minus sine squared of x is not just cosine of 2x. That's twice sine of 2x over cosine of 2x? Or what's sine over cosine? Just tangent, right? And that's what we wanted. Sine to the fourth of a. We can write that as sine squared of a all squared, right? Sine squared, though, is 1 minus cosine of 2a all over 2, or a half of 1 minus cosine 2a. Distribute that squared through. So quarter, 1 minus cosine of 2a all squared. Expand. One minus twice cosine of 2a plus cosine squared of 2a. But we don't like that cosine squared of 2a. Cosine squared theta is a half of 1 plus cosine of 2 theta. In this case, theta is 2a. So we're going to get a half, 1 plus cosine of 4a. Half times 1 is a half, plus 1 is 3 halves. We get a quarter, 3 halves minus 2 cosine 2a plus a half cosine 4a. Distribute that 1/4 through 3/8 minus a half cosine of 2a plus an eighth cosine of 4a as desired. I want to do this one. Going back to this. Let me start here. No, that's not going to work. Okay, that's what I'm going to do. Okay, let's try this. Start the right-hand side. Factor out a secant squared from the first two terms. And if you look at secant squared minus 1, that's just tangent squared, right, by Pythagorean identities. Secant squared, however, tangent squared plus 1. For tangent to the sixth minus tangent to the fourth plus tangent to the fourth, I forgot to put an X there, minus tangent squared minus tangent to the fourth plus tangent to the fourth minus tangent squared plus tangent squared. You're left with just tangent for this text. Good. So don't leave just yet. So those are the assignments coming due, right? Here's what I'm going to do. I'm going to give you another bonus opportunity for exam 3. Go ahead and complete that in class. I'll give you a chance for +3. 1 for each of sine, cosine, and tangent. And so turn that in. What time is it? It's 11:25, so that'll give you 15 minutes. Right, that'll be due at 11:40. If you don't want to do it, you're free to leave. Right, so Wednesday we'll look at the final 2 identities, product to sum to product. That shouldn't take long, and we'll also start solving trigonometric equations.